I did tell you yesterday. All right. I know that says a whole bunch of sample stuff, but let's make this make sense. Okay. I told you yesterday that we would discuss this section, and so I want to see it sounds very, I don't think it makes sense if you just read it, so let me see if I can describe it in a better way so that it makes sense, so that it can make sense in a common sense way. All right. So, let's first pretend, let's use this problem as an example. It's about weekend deaths in the emergency room. In a sense, they're trying to imply that if you go to the emergency room on a weekend, then you have a higher chance of dying, right? That's kind of what it's implying. It's implying that the fact you're going on a weekend, you have a higher percent chance of dying, so watch out, don't go on the weekend. Something along those lines. Okay, well let's just say that weekend and weekday deaths rate are the same. Say they are the same. Alright, so Zach is going to pick some random files from the weekend. Okay, Taco's going to pick some random files from the weekday. Now, if I compare their percentages, one's weekday and where they really are the same, are they going to get exactly the same percentages? Why will they be not exactly the same? Because they are random. There's a little bit of variation from sample to sample just because you pick different files. Okay, that's called sampling variability. So there is going to be some difference from sample to sample just because you picked different samples. And that should be, a certain amount. That will be within a certain amount that numerically we'll learn later. Well, what happens is this. If there really is a difference in the weekend rate and the weekday rate, there really is a difference, then what will happen is this. Zach will get what's in on the, what were you, weekday? Okay, Zach will get the weekend sample. Taco will get the weekday sample. And those will be much more different than just a little different. It will be statistically significantly different because it's not just because of regular sampling variation. They will naturally vary a little, but it's going to vary a lot. It's going to be statistically significant, and that's how you know that there really is a different rate on the weekend as opposed to the weekday. So, and you will not be quizzing on this. I'm just planting a seed. I do not give you something right before the quiz and then quiz you on it. I mean, what's the point in that? Can you listen, for the few minutes before? Okay, so let's see if this makes sense. Samples vary from sample to sample, right? We just talked about that. So this is called sampling variability. So that's a natural differences. Statistically significant means that the difference between the two samples is much more different than just regular simple variability. Just regular, it's much more different than just sampling variability. Okay. Ta-da. That makes sense now? So, let's then go on to these other parts. Okay, this study was an observational study. It's retrospective. Do you remember retro versus prospective? Retro is looking back and prospective is looking. Okay, and we know it's a study because there is no treatment. If there's a treatment, then it's called an experiment. Okay, so based on this information, do you really think that if you get sick, that maybe you shouldn't go on the weekend and you should wait until the weekday because there's a bigger chance that you're going to die if you go on the weekend? Do you think that's what this is saying? Okay, so this is a testament to why the weekend is not the cause of more deaths. I have a reason here why I think the weekend is having a higher, I don't really actually like it. I think there's another better reason that my students came up with. Because quite honestly, I have a confession, I have no common sense. I never have, and I probably never will. Any common sense I have, I've just kind of learned to mimic it from what I've learned from my students. And so I really don't think this is probably the best answer there is. I got a better one. I put that if people are really, really sick on the weekend, then they're going to go to the ER. If you're not too bad, then they'll probably wait until the weekday because it's more expensive and stuff to go on the weekend. And so y'all might not necessarily know that. Other people told me, what's happening on the weekend?
Party.
Yes, much more risky behavior. People driving under some influence of whatever. So much more risky behavior is happening on the weekend. It's not people going to work, going to eating dinner, going home, eating dinner, go to sleep. Going to work, going home, eating dinner, going to sleep, whatever. Much more risky behavior. So a higher percentage of incidences occur on the weekend. That's probably what it is. Now, this is called lurking. The riskiness, the more riskiness that's happening on the weekend is making it look as though weekends and higher death rate are linked. Remember, lurking makes it look as though two things are linked, but they're really not. The higher riskiness of behaviors is what's really the thing attributing to those. Do you remember confounding, by the way? Confounding clouds the issue and you can't tell what the cause is. Confounding clouds. Example, the tomatoes. There's two things acting on the tomatoes, the fertilizer and the sunny atmosphere. So you can't tell if it's the fertilizer or the sunny atmosphere. Clouds the issue. Confounding clouds the issue, you can't tell the cause. Lurking makes it look like two things are linked. Alright. Any other questions about that? Okay, next. This is the subjects were the chubby dogs kept as pets. Okay. Hey, listen to this. The explanatory variables are not Diet A, Diet B, Plan 1, Plan 2. No. The explanatory variables are like the factors, the hula hoops. In fact, I'm not going to describe it as factors anymore because I've realized that AP doesn't. AP just calls it explanatory variables. So you're going to go, your dog, you're going to go through one hula hoop. That's your explanatory variable, and that hula hoop is type of diet. So the type of diet is one explanatory variable you go through and you get assigned to you. And then you go along and guess what? Type of exercise plan is the other thing you go through and you get assigned to you. So there's variable diet and the other, because it's A and B. See, it varies. And then exercise plan is the other variable. See, plan 1 and 2. It's varied. The response that you are measuring is the percent weight loss. The number of treatments is 4 because I drew it out here, and so you can see there's 1, 2, 3, 4. And as far as the blindedness goes, I never really know if you can call the dogs blind, but I think really you do not. You do not ever need to put a placebo effect do not put a placebo in there, because it's not like the dog is going to go, oh, hold on a second, I'm thinking that I'm actually losing weight, and so I'm feeling better, and so I'm going to exercise more, and so the dog's not going to change its behavior because it has a conscious decision about the treatment. Okay? So the dog's not ever going to be considered a blinded thing. You don't ever need to give it a placebo. Now the evaluator, do you think we need to give the evaluator a placebo? This evaluator is the person at the vet that says, this dog now weighs 24 pounds. Do you think the evaluator has the ability to go, hey, you know what? It says you weigh 24 pounds, but I really think you look like you weigh 26. So do I need to do any kind of blinding with the evaluator? No, I think the weight is like done, it's there. Now it doesn't say anything about any of that here, so I kind of changed the question. You can't blind this, or you don't need to, and it doesn't say anything about blinding. Next. Okay, here comes our back toes and forks list. Okay, a couple things I'm going to say about this. One is this. The response variable is going to be stated somewhere in the problem. Right here is where it states that what is being measured, the response is the number of hours these machines can be used before repairs become necessary. Okay? So keep that in mind as we go through this. I thought that when they said you had 20 newly manufactured machines, I didn't take it as he gave them to you. I took it as I had the ability to randomly select them. And I don't think you would be counted off on that. I think it was left, that was an interpretation left up to the right of the person. So I randomly selected 10 backhoes, 10 forklifts, and you're going to be so proud of me. I did not actually put the backhoes and the forklifts in the bag, but their serial numbers in the bag. Okay? All right. So I put the serial numbers of all the backhoes that they have coming off the assembly line in a bag. I pulled out, I shook it well. I pulled out 10 numbers, and then I repeated for the forklifts. So I got 10 backhoes and 10 randomly selected forklifts. I blocked by machine, and here's the thing. You tell me why you blocked, and it better be tied to the response. I blocked by type of machine because I think the type of machine may affect the response, which is the number of hours before the repair becomes necessary. Now, did anybody use a different character trait to block on? I had it done this today, and I wanted to see if you did. And they're blocked by another trait. Okay. Then I need to tell you this, and I want to tell you how it's still correct. Here's how you still make it correct. I had people block it on the rigor of its use. So they said like high, rigor of its use or whatever, like for farming, and then another for ranching. So apparently they thought that the type of usage it would go through, the type of usage. So they put high usage, medium usage, or like difficulty. And here's how that could be correct. If you said, I will block by type of usage because I think type of usage is going to most affect the number of hours that you prepare before repair comes necessary, and that's great. So you have backhoes and forklifts in your group, but you think that you controlled the usage because you thought that was the characteristic that was most going to change the response, and then that's fine. Okay. After that, you randomly assign to the treatment groups. I had 5 with the additive, 5 with the out in both blocks. And here's how I said I did that. Put 10 items in a bag for each block. In a big bag, shake well. Oh, see, I put the whole item, so I had to get that in there. Pull out 5 items for each group treatment, each treatment group. And then, remember what goes next? You're telling me what we will measure. And what we are measuring in this one is the average number of hours. So in each group, you're going to get the average number of hours before repair comes necessary. I didn't make that up. That came straight up here from this top. I did not want to write that 4 times. So do you see how I just like put ditto marks or threw the arrow down? You can do that. You can say repeat within each group or whatever. So you don't have to rewrite everything. And then, of course, I have the comparing. Okay, any questions about that design? I'm going to talk about one other thing I did here in a second. Any other questions? Yes, at the end you say compare those things and compare those things. Oh, do I do another one like this? No, I probably wouldn't compare that. And you don't need to. You can just compare within each block, and that's probably all you need to do. Now, there was another question that was this. Are there any measures? Oh, there we go. Are there any measures? That's all off now. Are there any, let's see here if I can fix that. There we go. The question is this. Are there any measures that you would take to eliminate potential source of bias? So what you may have written because of that is you may have said, I randomly assign so that I'm not imposing any bias on which machines go in which group. Maybe one of them looks like it has more grease on it and it's going to do better. I don't know. So as long as you don't have, so you're making sure that you don't have any unconscious bias there. I personally put a blindingness into effect. I don't think this is really necessary unless they said, is there any blindage that you would do, and if so, how? I said I would not let the owner of the mechanic know if the machine had the treatment or not. Just let them think it was a normal machine. The reason I thought that is because if I was the owner and I knew it didn't have the additive, then I might think at the first sign I hear something, I'm going to go, oh, I don't have the additive. I better get this thing into the shop. Okay? So then that might change or skew the hours before I take it in. So I thought probably nobody should know, and since the mechanic is going to be the evaluator, he probably shouldn't know either. And then the last question is actually related to the thing I just taught you today. Explain how you would decide if the additive has solved the problem. And that means that the difference between the results was much more than just sampling variability. The difference between the results was statistically significant. It was much more than just sampling variability. Difference from sample to sample. Okay, done. Any question on that? Okay, then the 4 things that you are going to turn in this order are your Chapter 13 homework part 1, your Frappies, your Chapter 13 homework part 2, and then turn in your warm-up even though I did not stamp it. I know you haven't been able to write all that down, so I'll be able to see if you did it. All right. Any other questions? Okay, guess what? Pretty sure that all that just happened. I didn't even. Oh, there it is. It's recording.